Good morning, good afternoon, or good evening, depending on what part of the world you're joining us from. And welcome to the webinar on the GV Series 4.1 software configuration. I'm Chuck Kelly, and I'm joined here in the Nautel webinar studio by Scott Marchand, FM project leader. Good morning, Scott.
Hi, Chuck. How's it going? And hello to everybody.
It's a lovely day here in Nova Scotia. A little bit of cloudiness, but any day at this time of year that doesn't have rain or snow is good. It's good. It's all good. We're also joined downstairs in the engineering lab by Leah Hassan, and she's a technologist here at Nautel, and she's going to help us with some of the demonstration for today's webinar. And we think that that's going to be a very powerful part of this webinar. What we're going to talk about, and there's a lot to talk about, are the new features of the GV series, and assuming that you have gone ahead and bought, like so many people have, a GV, how you can go in and start configuring these features now that the newest software that supports them all has been released and is available to you. So this will include the simple site control feature, the automatic audio switchback, the oscilloscope, RBDS, RDS, PS scrolling and radio text, the RDS alternate frequency table, SNMP support, remote analog outputs, which are now configurable via the AUI, HD-only IBOC mode with HD power boost, local remote control, which is now remote enable disable, which has been something that people have been asking for a long time. A bunch of extra functional enhancements, pages and pages of them, and as well some enhancements to the spectrum efficiency improvements. We're actually going to integrate the live tour into the whole presentation. So we'll describe the feature, then we're going to show how the test is set up, and then we're going to actually go to the AUI in the test room and demonstrate how to configure that feature and show how it works. And then we'll take your questions, as always. So on the right-hand side of your GoToWebinar application, there's a place for you to be able to enter questions. We will take those questions at the end of the webinar. And please do feel free to ask questions. So let's get started. First off, just to introduce, the GV series is a new series of FM digital transmitters from Nautel. It was introduced at the NAB show and promptly won both the Best of Show from Radio Magazine and the Best of Show from Radio World Magazine, and we couldn't be prouder of that. Congratulations, Scott.
Oh, thank you.
And you've got quite a string of those things now. You've got a whole corner in your office dedicated to the awards.
To get full, yeah.
And these are very advanced digital transmitters, and when I talk about digital, it isn't just HD radio, although we think they do the best job of HD radio in the world, but they also are capable of supporting other digital modes, including DRM+. So this is a world-class digital transmitter. It's very efficient. We focused on efficiency with this product, and we focused on a lot of intelligent features, so we'll talk about all of that. So the first feature we want to talk about is site control. I can't tell you how many people asked me for this. They said, Chuck, I love the AUI, but I use that exclusively, and I don't know why we have those parallel inputs and parallel outputs, because nobody's going to use them because they're using the AUI to control the transmitter and monitor it. So why can't we turn those around backwards and make some use out of them? And that's what we did. And so why don't you explain what your perspective on this is, Scott?
Yeah, so I mean, this idea, this concept has definitely been around for quite some time. And in principle, it does take advantage of these really sophisticated inputs and the AUI itself. And it allows us to control and monitor external site equipment, repurposing some of those digital inputs and outputs that are readily available. It integrates so perfectly into the AUI to provide status. You can configure via the AUI, provides logging, and a really nice feature is it gives us notification capability via email in the event some of now your external equipment, not only the transmitter's internal equipment, but the external equipment that you're monitoring somehow misbehaves or moves into a state that you really want to know about. And the really cool thing about this is as we go in and run through this demo is it's some really interesting and even complex. If you have that sort of application, you can really create some complex as well as simple, of course, Boolean expressions to manage all of your site requirements.
Let's talk about, just for a second, before we get into the specifics of how to configure, what would people potentially use this for? What thoughts have you had?
Well, this demonstration specifically, the one that always comes to mind would be, monitoring the state of a thermostat, let's say in your site, and in the event the thermostat goes above a certain threshold, a contact closure would activate the transmitter. The transmitter would detect this. The user would be notified, and it actually could turn on an air conditioner, for example.
Sure. Another possibility might be a switch at the front door that says that somebody's come into the building.
That's right.
And that could then create an email and let you know that somebody's come in the building.
From a security standpoint, that's absolutely. And it's logged, so you know how frequently they've come in or how frequently the temperature has exceeded a certain point. So it can. I'm sure the possibilities are endless. And it's really simple to use. I think most people will find that.
So now let's qualify all this by saying, even though you could potentially start a generator, we don't have 600 amp contacts in the transmitter. So it may very well be that you're going to need to have an external contact or a relay or something like that.
Sort of intermediate control circuitry.
That's right.
What we provide is open drain in this case for the outputs. We provide open drain logical states, so they're either open or current sync to ground, and then the inputs are opto-isolated inputs where the user can, of course, leave the input open or some high state or current sync to ground to activate based on the logical setup within the system.
Okay, so let's take a look at this demo that you've set up, and you've got a little photograph on the left showing Leah and the switches that she's going to be adjusting here, and,
right.
and a little bit of a schematic on the right-hand side.
Yeah, for us visual learners, I drew a little sketch just to give people a sense as to what the text above suggests. So let me just run through this. So, so in this demo, the logic that the site engineer wants to implement is that he wants the air conditioner to be activated and enabled if the site temperature is high, but the vent itself, there's a vent in the room, and that has to be closed. But also the generator has to be off. And in this case, the generator can't handle the air conditioner, the additional air conditioner load on top of the transmitter, and therefore the air conditioner cannot turn on in the event the generator is also running. So if the vent opens, you turn the air conditioner off, or if the generator is on, you turn the air conditioner off.
Just like writing software, this is subject to the old GIGO. You need to be able to define this first before you start.
They are simple rules, but absolutely they need to be defined.
Yep.
And for those comfortable with Boolean expressions, the ands, the ifs, the ors, and then of course the active, high active, low states are very, very simple. So the system configuration itself, we've used the standard remote interface board that comes with every GB transmitter, and you can see in the picture to the left bottom that there are 3 switches that are wired into the terminal block at the top of the remote interface board, and specifically they're remote input 8, input 9, and input 10, representing the vent open active low. So that logic, that little convention suggests it's a digital state and it's active low. So if the switch would close, therefore grounding input A, input 8, the input would be considered true. And we'll go into the actual setup of the AUI and the remote I/O pages, but this is just giving you a rundown of how it's configured.
And this example really isn't important.
No.
It's just a way to understand the goal we're trying to reach and how we go about doing it.
And the fact that it doesn't matter how many inputs you select. You could literally have one input driving an output. Right now we're using up to 3 inputs, so it's a good example to show you how complex your Boolean expressions can be, but it's not overwhelming.
Right.
So now input 9 is tied to a site temperature high, active low, so some thermostat contactor, and then input 10 is the generator on, active low. So what this means is if the generator is on, that input is tied to ground, and therefore the system can understand the current state of the generator.
Right.
And then the interesting part here, and we'll go into more detail about what are termed virtual outputs and physical outputs. We've actually taken the output of our expression and tied it to a physical output, which is termed activate air conditioner. So that drives the external air conditioner control.
Okay. Shall we go to the videotape and take a look here and see what it looks like?
That's right.
Now here we are, and we're on the screen of the AUI.
Yeah.
What do I want to do here?
So specifically, let's go to the menu Remote I/O, and we're going to show users the inputs page, because that's where you start.
Okay.
Right.
So
of course, once you've defined your logic, because that has to be written down into the site control tab later on, but you need to have those set of rules outlined.
Okay.
So we're going to scroll down to remote input 8. That's the first input we're going to use.
Here. Yep.
Now remember, another thing I want to highlight is when you receive your GB transmitter, all of these inputs have a default setting to them.
Right.
So you have to be aware that you do need to repurpose these inputs. You need to redefine them. And in this case, you need to set the channel to custom input.
Okay.
If you actually hit the channel button to the right, you'll see all of the available inputs. And a lot of them look familiar because those are the default inputs. And of course, if you have more than one preset, you'd also see that. But you'll see at the bottom of the list custom input. So that's the one we're picking. You can just cancel out of that because this is all set up. We're just going to run through it. Then you pick your control. So what do you want the state of that input to represent, true or false? So if I have a low, and most of the time our inputs and then outputs you'll see later, we put them in terms of active low because they're either current sync to grounds or someone is grounding an input.
Right.
So we say in the state active low is true. So that means, based on the name we pick at the bottom, the vent is open if the input is low.
Right.
So the level field shows us the current state.
Okay.
So 0 would be low, 1 would be high, therefore the vent is now closed.
Okay, so let's ask Leah to push the button.
Right.
For the vent right now, we should be able to see that change to 0.
We would see it change.
There you go.
Right. Now, the other thing we want to do while we're here is just touch on the severity for a second.
Okay.
So low, medium, high. That ties into the notification portion and the logging portion.
Right. We want alarms to be.
Right. Now, you have the choice. You don't need to necessarily have an input litter your logs if you're concerned with frequently occurring state changes on certain inputs.
Right.
But you can put it there if you do really want that notification. So the next field below that, checkbox, is log. Do you want the status screen to be updated, and do you want them referenced in your logs?
Okay.
We've got this one selected as yes.
Right.
We're going to go to the status screen.
Yep.
And we're going to see that the vent is open.
Sure.
And the level you see here is the severity level. That is a low severity level.
Right.
Just an amber single exclamation mark. Now we're going to get Leah to actually close the vent.
Go back to.
Well, we're going to watch it disappear from the status
I see
screen.
what you're saying. Okay,
Yeah.
go ahead.
There you go. It's
gone.
actually gone. And if we go back to the menu, Remote I/O
Yep.
page,
Right here.
Remote Input 8,
And 8.
we'll see that we're back to
Yep.
a false condition.
Good.
So that's our vent open status. We're going to go to Remote Input 9 now.
Yep.
And same thing applies, except now the name is Site Temp High. And I really recommend people use the name. The name is what appears in the status, in the logging. Make sure the name
Reflects.
agrees with the logical declaration. So in this case, Site Temp High, it's true, and the input would be low.
Now, I would make a suggestion here.
Absolutely.
And that would be to change the word high here to too hot.
Yeah,
And
I
the
agree.
reason is
To
because
not-
high and low are
to not
logic
confuse
levels.
low. It's funny you say that, Chuck, because just this morning I got mixed up with that one when I was trying to
I'm
set
not
the
the only
switch.
one.
No. So we just didn't go back.
Okay.
So great recommendation. So Site Temp High. Now this one we're going to consider medium. Maybe we're going to consider it high. It really comes down to the user. In this case, we're going to consider it medium, and we're going to watch Leah set the temperature high and low.
Okay. There
And
you
see.
go.
Now, it's interesting. You'll see the status button actually went red this
That's
time.
right, because
any medium alarm is
alarm,
going to
yep.
cause it to go red. It's also logged, and then we're going to go now to custom input.
10. Oh,
Custom input 10. I apologize. Remote input 10.
Yep.
And this one, as we described in the presentation, is going to be generator on.
Yep.
So active low is true. Right now the generator is off because the level is high. We're going to enable the generator. And now we're going to go to the status screen. Its severity is low.
That's right.
And you should also see.
Let's see how these all look on the log. There we go.
Yeah,
They're all happening like that.
Now, in this case, when we get to the logical expressions, you'll actually see that we've activated the air conditioner going through these scenarios because the vent and the generator was off and the vent was closed, and we simulated a high temperature, so of course that activated the
So now we want to look at remote outputs?
Well, actually, first, the remote outputs, you do them last.
Okay.
Because you need to go create your site control expressions. And then once you've created them, then you assign those names that you've created to a physical remote output.
Yep.
Okay. So until you assign them to a physical remote output, they're what are called virtual outputs.
Gotcha.
They are outputs because of the output of an expression, but they're not.
And they show up on a log, but they don't use a physical connection on the transmitter.
Absolutely.
Okay.
So the first thing we do, because we have 3 inputs, is we need to create an intermediate expression.
Right.
We'll call that AC statement 1.
Right.
And we're going to click on that, and we're going to go into Edit.
Yeah, see what's there.
And that's how you go in and create these statements. You have AC statement 1, severity in this case is low. You have the option to set delay.
Right.
And the delay would be, do you want, if the statement is true, do you want the output to be true immediately, or do you want a delay? Now, we have some options for delays, 1 second, 2 second, 5 second. There are various applications where you want something to settle out first, or you want to make sure it's true.
Does that timer reset if it comes back for a moment?
Yes.
Okay.
Yeah. So if the statement is no longer true for any period in time, the counter resets.
Perfect. Okay. Yep.
Unless you choose to latch it.
Gotcha.
In this case, now it's still, I say unless, no, sorry, let me correct myself. If the delay period is reached,
right,
and it becomes activated, and you've chosen to latch it, it will stay latched and
until you do a reset of some
kind. Right. It has no bearing on the delay itself, other than the fact that once it becomes activated, it latches. So you have the ability to latch the state.
It's pretty powerful.
Yeah, it is. I mean, it gives us some really interesting options, and then of course you have the ability to log the event.
Yep.
Normal logical operators, your AND, OR, exclusive OR, and then your logic is true, is false. It depends on how you want to write the expression and how you've written your input names. When you go to your input drop-down menu, this is where you get to pick from all of these inputs. And you can actually pick from any remote input option. You can actually pick from any alarm.
Right.
It doesn't have to be just the custom inputs. It can be anything.
Well, you
it
could
can
also,
actually even
instance,
be outputs that you've
created.
created.
There's a thermometer inside the transmitter that looks at the air temperature. You could
That's
also and that.
You could actually use that. So if that alarm was active,
it
would be used in the expression as you see.
Fair enough. Yep. Okay.
So in this case, we've got site temperature high is true. So if that's true, if it's high, but the generator is false, so it's not on, it's off, we are going to say AC statement 1 will be true.
Correct. Okay.
Now in this case, you can see now the last statement, so you can see easily the things you've configured for that virtual output. We've got AC statement 1 low, latching is no, you want to log it, no, and you want the delay to be immediate, and then it's triggered when the control site temp high is true and the controller generator on is false. Now you can see to the right there's a field called state, a column called state. If it's checked, it means it's true. If it's not checked,
I see. So if we
it's
ask
not true.
Leah to make it true,
to make that condition true, so if she turns
she's done it.
Right. So now it's true, and in this case, we've used that expression as a term in the next expression.
Right.
And you can do this continually.
Sure.
You can keep adding, and that's how you create complexity in your expressions, by adding these virtual outputs, which are combinations of 2 terms, a maximum of 2 terms per statement. You can keep adding them and
chaining
make some
them
chain them and make some really complicated ones if you want.
My mind's boggling with this, but then I'm simple-minded, so that's okay.
Yeah, having worked with you for a long time. Well, maybe I won't.
Okay, activate air.
So activate air conditioner. In this case, that's high. We really want the severity to be high. It's not latched because we want the air conditioner to be able to turn off. And We have immediate latch log. Yes, we want to log it. And now we've pulled an input AC statement 1, which was created prior and is now available in the list. The logic is if it's true and the vent is false, see, so vent open is false, that means the vent is closed, yes, you can activate the air conditioner. And that's how we've created these OR statements. If the generator is on, you cannot activate the air conditioner, and if the vent is open, you cannot activate the air conditioner.
Simplify this for me for a second. If we go through this process and we turn on the air conditioner, and then one of the things that comprise that turning on the process becomes no longer true, the temperature in the room goes down or whatever, it doesn't turn back off the air conditioner?
It will turn back off the air conditioner, assuming the air conditioner control input reacts to the change of state of that physical output.
Okay, so that's where I was trying to understand. What's the difference between latch and not latch?
Latch would not turn the air conditioner off because the output state, if ever true, would stay in the true state.
So in that situation, what we could do is we could have another set of circumstances that would result in turning off the air conditioner.
Correct. Correct. Assuming your input could, the input of your air conditioner could accept multiple inputs, right? Obviously, it's going to take precedence on a low or an active low, so you have to be careful not to parallel up more than one state. But yes, yeah.
All right, good. All right, anything else we need to show here to this process?
You know, other than the fact that let's go into menu, user settings, and
user settings,
and we're going to go into notifications, and maybe we'll touch on email configuration first.
Okay.
So someone has gone in, and Leah in this case has gone in and set up her email, email port information, name, and so on. And then the notifications we've created specifically for this webinar, we'll go in and edit our webinar, and you'll see we created when the air conditioner has become activated. I want notelwebinar@gmail.com to be notified.
Yep. Okay.
So yeah. So and again, from the available alarms, anytime you create a custom input or a virtual or physical output, you can go and pull it into the notification.
And one thing I really like about this feature is there may be different conditions where you would want to send emails to different people. So for instance, in your station, if the audio coming from the studio goes away, it can generate an alarm to send an email to the program director.
Correct.
And if the VSWR on the antenna goes high, it could send an email to the chief engineer.
Absolutely.
Completely different scenarios.
Not a mass distribution list. It's a very selectable distribution list. So the last thing I want to do here, because is the remote outputs. So we want to go to menu.
Okay. Yep. Back
remote
to
I/O.
Here. Yep.
And now that you've created your logical statements, we're going to go down and use remote output 16.
Right. Yep.
We said, okay, which channel do we want to use? I can pick from any input, alarm, and so on, or virtual output that has been created.
Okay.
This is the process of assigning a virtual output to a physical output.
Yep. Okay.
And then the logic would be, in this case, low when true.
Right.
Output low when true. So that means if the statement is true, I want the output to be current sync to ground.
Yep.
So assuming your air conditioner, and in this case, I guess you can see that it's true. Yep. And if Leah would create a scenario, drop the temp, we should see it go false again.
Go to 1 here, but it hasn't.
Go to the status.
Yeah, I saw it take in the status. Yeah. It's not there anymore.
Go back to the menu page.
Yeah, maybe I just need to refresh that. And then outputs.
Go to 16.
Yeah. There it is.
Yeah.
Okay, good.
So in this case, it's no longer true.
Right.
So that's pretty much all I wanted to cover on the site control.
All right, let's go back here then, and let's talk about audio switchback.
Right. So this really complements an existing feature. It allows and again, another customer request where you have main audio, and we wanted to be able to return to that audio in the event it would recover post a switch to a backup source.
Right.
So there's a mod loss timeout function. We'll discuss that, and it really allows the user to have more redundancy with multi-tier backup audio loops. And at the bottom of the page, you can see a very simplified view of that, where you have two presets, and this is tying into the demonstration. You have two presets. MPX is the desired input, and you have left mono as the backup for the first preset. Failing even that, you can switch to preset 2, where you might have a USB backup.
Okay.
So we'll actually run through our demo, and we'll quickly, actually, why don't we switch back to that presentation. We're just going to run through the system config.
Oh, yeah, sure. There we are.
So I'll quickly focus you on the drawing to the right. So I've got a GV5, this is in the lab. I've got, on my MPX input, I've got a 1 kilohertz tone at 100% modulation. On the left mono input, I've got a 2 kilohertz tone at 80% modulation. In that preset, which we'll go look at, my main audio is the MPX, and my backup audio is the left mono. Within the preset also, I've got the mod loss timeout set to change from preset 1 to preset 2 if preset 1 modulation falls below the threshold of 15% for a timeout period of greater than 10 seconds or more. Preset 2, this is all part of this loop, my desired input is still MPX. So if I've changed to preset 2, I always want to recover to MPX in the event it recovers at all. So MPX is still my main audio source, same settings. My backup audio in this case, though, is not left. It's USB playlist with an MP3 file. And then I've got a timeout setting very similar to the above, except that I'm now changing back to preset 1. That closes the loop.
Okay.
Same settings. One thing I will highlight is that the main audio low trip level, which we'll go into that menu really quickly, where the user would actually adjust some of these timeouts and trip levels. Right. Right now is set for about 7.5% with a timeout of 5 seconds. The mod loss timeout thresholds and timeout periods have to be greater than the main audio low trip levels in order for this to work. Otherwise, the mod loss timeout would shift the preset before you have a chance to go to the backup.
Do these minimum modulation levels include the effect of FCA, RDS, pilot, all that stuff?
The main audio low trip level, no.
Yep.
It's strictly the main audio, whatever is main for that preset, because in that menu there's also an FCA audio trip level. The modulation loss is the entire composite baseband.
Okay, so you've got to make sure you set that percentage above 9% or whatever
if you have RDS,
use for.
if you have any SCAs, yes, you know, you don't want them to affect the transfer.
Good. All right, so we'll switch back to here, and we'll head down to presets.
We're going to go into presets, and we're going to just skim through our main audio parameters, and we'll see, as I described, MPX is set for 3.5 volts peak to peak. We have an external generator running for pretty much exactly 100% mod. You can see on the top right corner. Transmitter's running at 1 kilowatt. I've also changed the power level between presets just so users can see, in addition to the modulation parameter changes, you can see the power level change.
Okay.
And then in preset 1, you've got audio backup is enabled. In this case, we've picked analog left and right. We've got a 0 dBu reference level. Again, another external generator feeding that input, but this time with a 2 kilohertz tone.
Okay.
So we will quickly run to the other settings and look at the mod loss timeout parameters. So we have a change preset to 2 with a 15-second percentage 10-second threshold. So now let's go back to the main page. And we're looking at the RF spectrum now. We have a choice. We can look at the audio spectrum. So let's go look at the MPX.
Yep.
The gear cog.
Like that.
Okay. So if you put your marker on that little tone.
Actually, let's make it full screen.
Sure. Just for a second, because we'll want to come back and look at the...
yeah, I'm close. Well, I can go...
Just use your arrows.
Yep. There's 1 kilohertz.
1 kilohertz. So there's our MPX tone.
Okay.
So let's minimize that.
Right.
And you can see to the right the oscilloscope, and we'll get more go into more detail with the oscilloscope in a second, but you can see it is free running.
Sure.
And you can see the blue trace is MPX. So and actually you can tell with the time base, it's 2,500 microseconds, which is 2.5 milliseconds. It's approximately 2 divisions, which is a millisecond,
right?
Which is
there you go.
Kilohertz. So now what we're going to do is we're going to ask Leah to pull the MPX source.
Okay.
So now we've lost our MPX.
Right.
And in approximately
hey,
5 seconds, we're going to come back on at twice the frequency because we're actually running with the
twice
left.
the frequency here into the oscilloscope, but you could also take this full screen and you could see by going to here, like that 2 kilohertz is now the frequency.
Absolutely. That's our left input with a slightly reduced 80% modulation depth. Oscilloscope, again, gets updated easily. And, yeah. So the next thing we're going to do is we're going to plug the MPX back in because we want to automatically recover to MPX, and you can see we just did that. And it's immediate.
Yeah.
There is no delay. When the MPX comes back, we switch back immediately.
Okay.
So now we're going to do our little loop that we simulated.
Pull both of them.
Right. We're going to pull MPX first so that we can switch over to the left.
Right. Okay.
So I'll ask Leah to do that.
There it goes after 5 seconds.
Yeah.
And we're back.
Right. Now we're going to pull the left, and it should transfer after 10 seconds to preset 2.
Okay, it's been pulled.
At which point it's going to immediately look for MPX because that's our main source.
Sure.
It's going to identify that it doesn't exist because we still haven't reconnected the MPX.
Yeah, it just has looked to MPX, as you can see
right.
here, and USB is second.
And
now
the USB has come up, and we're pulling in, I think, Megan Trainor, for example.
Right.
Now, what's interesting here is in the second preset, which we didn't review, we had set up the mod loss timeout to go back to preset 1.
Yep.
Now, we've also set up this USB, this MP3 file, to have 15 seconds of audio and then some dead time.
Right.
Some off-air time.
So it's going to go ahead and switch
Now
back.
it has just switched back to preset 1.
Yep.
Left is still connected because I actually set this up where Leah would set up the left once we did the switch. This way it wouldn't recover to the MPX automatically in preset 2. It switched back to preset 1, said MPX is still not there. Now it's running at 2 kilohertz on the left channel again.
Perfect.
And now we're going to reconnect the MPX and get ourselves right back to square one. It will shift back to the desired MPX input.
Perfect.
Okay.
Excellent. Well done.
So
next up, the oscilloscope, and we've been playing with that.
Yeah, so this should be, we actually saw it in action. So the advantages of this, I mean, we plan on expanding this feature even more, which is I look forward to. But it really just gives a time domain view of pre-correction forward reverse signals if you're in IBOC mode. So that gives users the ability to assess not only, well, mainly the linearity of the system, both in amplitude and phase, to see if your forward and reverse signals are aligned and the proper gains are set up. But as we were just looking, you can see the MPX audio, the left-right audio, and the audio, even the audio IQ signals. Okay.
So let's toggle over to that and take a look. So here is the oscilloscope that we've been talking about.
Right. So we've got exactly the same setup as before. We haven't changed anything. And we have the MPX source. So we can go in, and the drop-down will allow us to pick, of course, the forward, reverse don't apply. Left sources, you're probably going to get a little bit of noise.
Yep. So you can see that the left has audio and the right does not.
You can actually hit play because it's stopped. It gives you the ability to play and stop. Okay. And then you want to go back to the IQ.
Yep. All right.
And we'll go back to that because I see what Leah just did for me. We were off cue a little bit.
Okay.
So she pulled the MPX so that when we went to the left-right, if you go back to the left-right.
Okay. Oh, I see. Yeah.
Yeah. The left-right wasn't activated because it was the backup.
Thank you, Leah.
We've got our left again.
Yes, we do.
Right? So you have to pick your source. It's like any tool, any instrument. You know, you have to decide what you want to measure.
Sure.
We do pick some pretty typical defaults to start based on your audio sources.
Yep.
But within the backup source, we're still looking at MPX because that's the main. So
okay.
just be aware it won't automatically switch for you.
Right.
You have to go pick your source.
Okay.
So
very good.
audio or IQ is the same thing.
Okay. And the cool thing about this is you can put this oscilloscope on your transmitter, and you could be 500 miles away and still seeing what's going on.
Absolutely.
That's the cool
Absolutely,
thing.
Yeah.
Okay. And then this is the demo that we just talked about. So
yeah, these were just the parameters, same exact setup, so no need to go through that.
Okay, now let's talk about RDS. This is going to be fun.
This is cool. So again, the cool
Keep
thing, I think,
this.
the message is everybody has been asking for this, and we finally responded. So you know, obviously we're pretty proud of that. But we now support PS scrolling. We're going to jump into the menu, the picture down at the bottom. You'll see we give the ability to turn it off, of course, and then pick whether it's a slow or fast scrolling. Slow would be somewhere around 10-second updates. Fast is approximately 3 seconds.
Okay.
And then, of course, you can pick word or character. So with every update, whether it be 3 seconds or 10 seconds, it's either transitioning by one letter if it's character or by a word, which would be, for the most part, every space if it can fit it within 8 characters or so.
Okay.
We also support radio text, which is up to 64 characters. The speed and so on is defined by the protocol. But we'll get to take a look at what that looks like.
All right.
And one honorable mention here is that we've increased our alternate frequency table from 6 to 25.
Not so big a deal in the States, but in Europe and other places, this is real now.
Yeah. So those complicated networks can be put in place.
Okay.
So we're going to focus specifically on the RDS portion of this. So we've got an MPX output sample that's being fed from the exciter in the GB5 to an RDS monitor. And I think this has never been done before, but we actually have a camera looking at the screen of the RDS monitor so we can get real-time feedback on what we're doing in the preset.
There's
Leah going to call us.
Right on time. Okay, so there's the camera. Hopefully everybody can see this all right. There's the camera. And
now we're going to go to the AUI, and we're going to go to preset 3.
Okay, so we'll go to the AUI.
And you actually want to, from the drop-down menu, pick preset 3.
Okay. Absolutely, right there. And we activate it.
Okay, so we've got our little RDS. Now we also have our MPX. MPX is the primary source.
Okay.
So we still have our 1 kilohertz tone. And in this case, you can see the modulation percentage go up to 110%.
Sure.
100% MPX and 10% injection on the RDS.
Okay.
So in the bottom right corner, you can see PS name,
This
static.
is the camera, right?
We're going to go to menu,
Okay.
preset,
Yep.
and we're going to go to RDS.
Right.
And we're going to see that scrolling has not been enabled.
Okay. So
This is where we have the ability to change whether it's enabled and then what speed.
okay, we'll try slow first.
So if we pick slow, remember that with it off, PS name static was displayed.
Right.
And that is, you can see the PS name field is displayed there.
Exactly. So I'm going to hit
You
save.
just save.
And it says I'm going to change the current status of the transmitter. And now we're seeing that information there, only it's slow.
That's
going to
right.
take 10 seconds.
10 seconds to update. Now we were going to have a little bit of fun with the field, something like Chuck likes turkey or something.
Oh
with
yeah,
the,
thank you, buddy.
Theme, but we decided to keep it pretty straightforward. So we have something to the effect of this shows PS name scrolling is enabled by word or character, or an example of PS name scrolling.
Let's make it go fast.
Yeah.
And let's see.
And that's actually pretty remarkable.
Save. Save. There we go.
So it'll definitely update more frequently, as you can see now. In this case, we're scrolling by word.
Right.
So we actually want to, maybe we want to change by character. When it's slow, it's painfully slow.
Yep.
But if we have fast enabled by character, you can see that it'll shift every 3 seconds by character.
Oh, yeah. Okay.
Okay.
Very good.
So now we'll get Leah to change the RDS monitor to the radio text field, and you'll actually see our radio text content.
There you go.
That's the more kind of what I would have been familiar with from a
Sure.
scrolling standpoint.
Much more typical.
Yeah, more typical.
Super.
So yeah.
All right.
So kind of cool.
That's how that works. And thank you, Leah, for that. All right. I terminated that Skype call. Thank you, Skype, for making that possible.
Yeah.
Let's talk about some other things that we're doing with this new GB software.
Yeah, so that kind of concludes those 4 major demos, but some other big things here is that we actually have SNMP support in the software release.
Okay.
Many customers will be pretty excited about that. I don't know if you want to go to the AUI.
Sure, let's just
show
take a look
them the
at
menu.
that. Yeah. So that would be
Menu,
yeah,
user settings,
right.
and SNMP configuration. So
Okay.
you've got some pretty straightforward parameters to fill in
Yep.
from an SNMP standpoint on the agent side. And then you have the choice to enable traps or not traps. And for those of us who aren't familiar with traps, they're really just unsolicited messages that are sent from agent to client or client to agent where I need some activity or action.
Probably a more commonly understood word would be interrupt.
Interrupt. Yep.
Yep.
Unsolicited interrupt. Yep.
Right. Okay.
Perfect.
Very good. And so then over
If you
here
go into the trap
configure
menu,
those.
that's
Yep.
where you can go set them up. So then you can tie them to specific alarm conditions.
Right. So in other words, the remote equipment doesn't find out about something that has happened in the transmitter only when the transmitter sends a regularly scheduled update.
Right.
It can find out right away on certain
Right,
things.
and sometimes, yeah, the SNMP controller on their end is only pulling information on a specific polling cycle. So this allows the transmitter to interrupt that periodic stream
And as is
ask for
true with the AUI in general, we're not just talking about a very simple remote control system or even a complex remote control system. The real magic of the AUI is the number of things you can actually choose from and learn about, and that's just under the controller. We could switch around other things too.
Exciter, yeah.
So it's far more in depth. That's really where the beauty of this comes in, because yes, okay, it's a very exciting user interface. But if that's all it was, it wouldn't be anywhere near as powerful as it is today because
Absolutely.
of the depth of information that
Absolutely.
we have in the transmitter.
And it's always expanding. I mean, we're
Yep.
very creative that way.
Okay, so let's go back to our little presentation here. Remote analog outputs are now configurable via the AUI.
Yeah, now in previous generation, this is something that was pulled out because we just didn't feel the page was intuitive enough.
Okay.
So we pulled it out of the AUI temporarily. It was still available via the UI, which is this backup user interface on GB, on the controller module. So now we've added that back to the AUI page, and we've changed its look a little bit. We've simplified it.
Yep.
So what this allows users to do is take advantage of, remember that remote interface board that we
Right.
talked about? There are 4 outputs on that, which are fed from a DAC, a digital analog converter.
Right?
This allows the user to take what is considered the full-scale power or reflected power, forward power, reflected power, average PA volts, or total PA current, whatever is the full-scale value of that meter, and scale the output voltage from that DAC that would be monitored by an external piece of
So
equipment.
if our transmitter was, this is a 5 kilowatt transmitter, and if this 5 kilowatt transmitter was running half power,
Right.
then the voltage here
If
could
it
be
was 6
configured
volts, yeah,
to be 3 volts.
that's correct. So,
Okay.
and I mean, if we did the simple math now, you'd see the scaling is 100%. That means we want to use all of those 6 volts.
Right.
If we went to 50% scaling, it would change that full scale reading, if it was 6 kilowatts, to half that, so 3 volts. Yeah.
Makes sense.
Yeah.
Okay, very good. Let's go back here.
So the other exciting work we've done, some more exciting work we've done, is we've actually now incorporated all digital operation into the PowerBoost core, and we were pleased to see the results, and they were expected results, but we were pleased to see the results at yet again higher efficiency numbers.
Okay.
And the other advantage of doing this, and the reason why we did this, again, customer requests, is asymmetrical sideband support.
Sure.
So we can go into the preset menu, maybe, Chuck, and look at how one would configure a preset. This transmitter is configured for FM only, but you can still go into, you're going to go into mode under general.
Yep.
That's fine. You're going to
Right
pick
there.
FM, drop down. Maybe we pick all digital, FM
Sure.
with HD, it doesn't matter. And this gives the user the ability to set up their lower or upper injection levels.
That's intuitive.
And if you want symmetrical, obviously the numbers are the same. If you want asymmetrical, then you make them different. So.
Fair enough. Okay, excellent.
Now, real value here, of course, is adjacent channel interference.
Sure.
Where you just cannot broadcast a high level of upper sideband, let's say, because you have an upper adjacent.
Nautels are good
customer.
neighbors.
Right.
Okay.
So we give them the ability now to be even better neighbors.
Okay.
The other thing we've done in this release is change philosophy, because, again, customers have been kind of against us for how we had incorporated our local remote control scheme. Prior systems would have been you're either local or you're remote. So if you're remote, you can't do anything locally.
Let's talk about the reason for that in the first place.
Yep.
The reason for that in the first place is somebody could be up at the transmitter site with their hands in the back of the transmitter. Now, theoretically, it shouldn't be powered up anyway, but nevertheless,
correct,
could be working with things associated with the transmitter. And if remote was enabled at that point in time, somebody could log into the AUI and make a change in the transmitter,
absolutely,
thus causing some angst on the part of the broadcast
typical
engineer.
scenario that I think of is antenna maintenance. So antenna maintenance at reduced output power, because I mean sometimes you do have to have a little bit of power, a few hundred watts, let's say. Someone logs in remotely and changes that set point.
Makes it full power.
And we've got problems.
Sure.
So,
okay.
So what we've done is it really didn't make a lot of sense to force the user to leave remote mode to go to local mode when they were on site.
Right.
Because the risk was many customers would forget to put it back into remote. Now, we've made lots of recommendations where users should put a big light bulb, and now you could use your site control function to drive that light bulb based on the remote status. Just it reminds you to put it back into remote. But we really didn't think there was a huge value to it. The real value comes from being able to disable remote. That way those remote users have no control, but you always have local control, because it was really as simple as putting it to local to get local control. There were really no other locks or measures.
A little bit more on the background of this. We heard about this loud and clear at several NUG meetings where people complained about having made the 2-hour trip down from the transmitter site and forgetting that they had left the transmitter in local control only mode.
A painful mistake.
Yeah, and we paid for it.
Yeah, and you know, obviously you cannot change the control state remotely. That would be
defeat the purpose of the whole concept.
Right, so
okay, very good.
The other thing we've done, and this I invite users to review the customer service bulletin notes that were issued when this release was made available. But we've done actually quite a few functional enhancements throughout the AUI, specifically menus that existed only in the user interface, the backup user interface. We've actually created pages now to make it easier for users to adjust those settings via the remote AUI and local AUI. So again, yeah, I do recommend people. It's a pretty long list. There's probably about 7 pages of little things and some bigger things. Of course, we're focusing on the bigger things, but
okay.
Yeah. And the next item is the spectrum efficiency optimizer performance improvement. So we had, you know, you can imagine with any new feature that gets released to the world, you start to get some feedback, and some feedback that we received was that we were getting a little bit too much overshooting if the HD data was actually lost on a GB transmitter. And it wasn't significant, but it made people uncomfortable,
sure.
and I can appreciate that. So we revisited the function, and we made some significant improvements on trying to limit those overshoots. I won't go into great detail as to why those overshoots happen, but you can imagine the spectrum is changing drastically, and the way this function works, it needs to capture that data. So we've slowed things down a little bit, and we've really greatly reduced, almost to a negligible point, those overshoots.
That's great.
And then, of course, for those who are wondering
what the heck is he talking about?
What's he talking about? This, of course, was introduced as part of Software 4.0 or 4.0 release.
So every
GB supports this. But really, what this function is, and we're pretty proud of it, is it allows the transmitter to automatically adapt to environmental conditions. So the system's operating point, the transmitter's operating point, varies greatly with load impedance, our antenna impedance in this case, and also the operating point of the amplifier. So
the injection
level,
yeah.
the operating point of the TPO. So all of those parameters can have a negative effect on the performance and the spectral performance specifically, and the efficiency for that matter. So what this function does is it continually monitors the spectrum and makes adjustments within the transmitter to bring the spectrum to still within compliance, but always trying to save as much waste power as possible.
Let me put this in my own terms. It was pretty cool when the AUI came out with the spectrum analyzer and you could see what the sidebands really were from your house or your cell phone or whatever you wanted to do. What's happening now is that the transmitter is looking at that spectrum analyzer itself. It's as if the transmitter has become self-aware.
Absolutely. It is.
And in fact, things like this, when you mentioned antenna impedance, can change. You can have icing occur on an antenna, and it can change that impedance. So this is dynamically looking at it, and it will actually make changes so as to keep you within spectral compliance at your targeted number.
That's right. It is configurable, and we can go look at the menu, but it is configurable. So we give the user options. For sure.
Actually, in the other webinars we've done, we've gone
into great detail. That's true.
So we'll just
trust us that it is configurable.
And just be aware that there are some really significant advantages to this technology. It makes the transmitter low for long. It allows the transmitter to adjust itself and stay cool and reduce the electrical consumption significantly.
Reliability alone is
absolutely. So just tying up a little bit of loose ends on the GB series, what we've been talking about today, it's the highest HD performance both in power and efficiency. It has a new site control, new oscilloscope, new spectrum efficiency optimizer, new audio switchback, RDSPS scrolling radio text, 25 position alternate frequency table, and there's a backup LCD user interface internal just in case that the screen in the front panel stops working for you. Power supplies will work down to 90 volts. You can stay on the air through brownout conditions at reduced power. And that means that 110 volt UPS is now possible. And there's audio loss switching built into the transmitter. And all of this is backed with the best support in the industry. We have a 4-year standard warranty, 24/7, 365 support, Nautel phone home, which I'm going to explain a little bit more in a second. The fact that we have never discontinued support on any product in our 45 years. Show me another company that can say that. And Nautel continuous improvement. We're going to talk about that in a second too. So Nautel Phone Home really is the beginning of Nautel's strategy of proactive service and support, where the transmitter actually tells servers here at Nautel that you have a problem. And that's a very, very valuable thing. We can find out what's going on, in some cases before you do. Now, bear in mind that this feature is turned off by default. You have to actually go in and turn it on because we're very careful about your own concerns for security and information. So, but it does allow the Nautel service engineers to understand what's going on in your transmitter. You call up and you say we have a problem, and that will automatically take care of that. So we'll know and we'll look at the meters and do whatever we have to do with the phone home. Now the question that a lot of people are asking, which is, which of these new features can be retroactively added to an existing NV Lite or VS unit? And the most important 3 features that are not hardware limited, for instance, the smart HD
the spectrum efficiency optimizer
doesn't work on an NV Lite, which is an analog transmitter.
NV, yeah.
However, our customers who have NV Lites, and there's tens of thousands of them now around the world, in sometime in this quarter 4, 2014, before the end of the year, we hope to have a software release out that'll gives you that audio switchback function, the oscilloscope function, and simple site remote control. You didn't buy those when you bought the NV Lite. You didn't know you were getting those features, but that's all part of the philosophy of continuous improvement, where we're constantly looking how to make the products that you already have from Nautel more valuable. And for the VS, we don't have a schedule yet. Can't say it's going to be this month, but we do plan on making these 3 features available as well in the VS as a free upgrade for you in the future. So Now we have an opportunity to go and answer your questions. And let me see if I can figure out how to make that happen now. Hang on one second. And we can do that. And we can do that. And I can show this. And I can do that. And now we're back somewhere close to where we wanted to be. And now I can start reading the questions. Okay. And there's a question about timing. We'll have to check that. The emails apparently have wrong timing according to this writer. I'm sorry about that, Alan. We'll have to check on that. You should use HVAC, so not to confuse with power AC. Good point. Good point. AC means air conditioning. It means alternating current. Thank you, Dave. And will these software features be available for the NV, VS, and NX transmitters? Says Marco. So we've answered that for 2 out of 3 of them. The NX, I don't know the answer to the question yet. There's enough difference between the series of transmitters that we're talking about that I don't know whether or not we'll be able to do that in the NX, but we'll find out and let you know as time goes by. It's certainly our goal to try to bring as many features and to have a common user interface platform. So if you know how to use a GV, you know how to use an NX or an NT television transmitter for that matter. So those are the questions that we got. Thank you for those questions. And we'll go on here and let you know that there are many places you can get additional information about Nautel. Do please sign up for our Nautel Waves newsletter. All the webinars are archived and available at nautel.com/webinars. We have a YouTube channel. We have the Nautel store where all the parts are available online. We have live chat for customer service. So many places, and we have LinkedIn. We have Facebook pages. We've got social media. We do social media here at Nautel. And lastly, I wanted to thank you for being with us today, but also draw your attention to this. The completion of a Nautel webinar does qualify for half of an SBE recertification credit, which is identified under Category 1 of the recertification schedule for SBE certifications. Nautel is a proud sponsor, a proud member of the SBE, and we do everything we can to support that organization, and we're proud to be associated with them in terms of getting credit for people who watch these webinars. And even watching one online later is useful for that credit. So please do consider that. Any little parting thoughts there, Scott?
No, I'm glad it actually went quite smoothly.
It did indeed. Yeah. Everything worked. Thank you so much for your efforts. Thank you, Leah, down in the test room for all of your efforts.
Thanks, Leah.
And we will talk to you again next time on a next Nautel webinar. Thank you so much for being with us today. I'm Chuck Kelly. Take care.